Today we will see how to play with different threshold value and see our model performance. We will discuss TPR, TNR, FPR and FNR. What is TPR? TPR is the true positive rate. It is the ratio of true positive divided by true positive plus false negative. Means this value divided by these two. This gives the true positive rate. The formula for TNR is true negative divided by false positive plus true negative. TNR is true negative rate. The formula for TNR is true negative divided by true negative plus false positive. Means it is the ratio of true negative divided by the sum of these two values. Then what is false positive rate? False positive rate is false positive divided by false positive plus true negative. Means this value divided by the summation of these two. The false negative rate means false negative divided by false negative plus true positive. Now let us discuss what this for. Suppose the confusion matrix for our model is this. Columns represent predicted value and rows represent actual value. True negative means actual value is negative and predicted value is also negative. Means it is predicted negative value correctly. What is FP? FP is false positive. Means actual value is negative but it has predicted positive. What is FN? FN means false negative. Actual value is positive and it has predicted it as negative. TP means true positive. Actual value is also positive and predicted value is also positive. And the values of TN is 50, FP is 10, and FN is 5, TP is 100. So total value for actual negative is 60. Means TN plus FP. And the total value of this row is Fn plus Tp. Means 5 plus 100 equals to 105. Same as this, calculate for column. Tn plus Fn is 50 plus 5 equals to 55 and Fp plus Tp equals to 110. Now calculate TPR, FPR, TNR and FNR. What is the formula for TPR? TPR is this, true positive rate. Means true positive rate divided by false negative plus true positive. So TP is 100. So 100 divided by 100 plus 5. So true positive rate is 0.95. True negative rate. True negative rate is this row, this value. So Tn equals to 50. So 50 divided by 50 plus 10, which gives us 0.83. Now let's calculate false positive rate. False positive rate is 10 divided by 10 plus 50, which gives us 0.16. Then false negative rate means false negative rate divided by false negative plus true positive. So 5 divided by 5 plus 100, which gives us 0.04. For better performance, our TPR and TNR value should be high and FNR and FPR value should be low. Means this both are true negative and true positive. These two should be high and these two, false positive and false negative, should be low. What is sensitivity? Sensitivity is the measure of proportion of actual positive cases that got predicted as positive. Means true positive. Actual value is also positive and predicted value is also positive. Sensitivity is also termed as recall. This implies that there will be another proportion of actual positive which would get predicted incorrectly. Means in some cases people has coronavirus but it has incorrectly predicted as negative, means false negative. The patient has cancer but the machine didn't detected it, so it is false negative. This can also be represented in the form of false negative rate, which we discussed previously, FNR. The sum of sensitivity and false negative rate would be 1. The value lies between 0 to 1. What is specificity? Specificity is defined as proportion of actual negative which got predicted as negative is true negative. Negative means the person didn't has COVID and the model also detected that person as negative, so it has correctly predicted negative. There will be another proportion of actual negative which got predicted as positive, means false positive. The person didn't have COVID but still machine indicates that that person have COVID, so it is considered as false positive. The sum of specificity and false positive rate would always be 1. Now I will show you this confusion matrix calculator. So what you should do, if you have confusion matrix with all these values, then put it into this Excel sheet, then it will gives us the value for all this classification matrix: sensitivity, specificity, accuracy, balance accuracy, false positive rate, false negative rate, and so on. So just put it in this column and it will calculate for us all these matrix values. Here I have put some random values. You put your values in this confusion matrix highlighted with purple color, and the total values for rows and columns will be calculated automatically. These are the classification matrix and regression matrix which are calculated by this Excel sheet. The values for this specificity, sensitivity, accuracy are calculated automatically. You can see the formula by clicking this cell. So if I click this cell, it will give the formula for this sensitivity, which is TP divided by TP plus FN. If you click this cell, then you will get formula for specificity, which is Tn divided by Tn plus Fp. The formula for accuracy is Tp plus Tn divided by Tp plus Fp plus Fn plus Tn. So you can calculate this all metrics and their values based on your confusion metric values. If you change your tab from this calculator to confusion metric formula plus example, so here you can see the formula for all the metrics and their examples also is given below. Here is some random values taken and calculated: specificity, sensitivity, true positive, negative rate, and this has shown the whole classification report from this random values taken as example. So you can try your values and see the values for all these metrics. I will put the link of this Excel sheet in the below description. So you can use that Excel sheet whenever you want to see the whole classification report, calculated metrics and their calculated values. Here is the flow. Apply different threshold values, then build classification confusion matrix. According to the use case, select which is more important: precision, recall, specificity or sensitivity. then analyze the performance of your model, and then finally deploy your model. So build this type of table. These are the sample number of rows. Their class is positive and below class is negative. These are the probability of this row lying in the positive class with 62% probability. This row indicates that this has 39% of probability that it belongs to negative class. So sort this value based upon the descending order of the score, probability score. So this gives us the table with descending order of the probabilities. So try different threshold value. If I take 0.82 value as my threshold, then value equals to 0.82 and greater than 0.82 will lie in positive class. The value below 0.82, which is 0.75, will lie in negative class. Same way, if I take a threshold value as 0.49, then probability values equal to 0.49 and greater than 0.49 will lie in positive class, and the values below 0.49 will lie in negative class. So you can try different threshold values and build the TPR and FPR, which is true positive and false positive rate values, and see which threshold value is suitable for your model according to the use case in the domain which you are building the machine learning model. This way you can see that trying different threshold values gives different false positive and true positive rate. So if you are building let's say a model for detecting COVID, then that model's true positive rate must be high, because the detection of COVID in early stage is more important than false positive rate. So according to your use case, choose suitable threshold value and use that threshold value for building model. Thank you. If you liked my video, then don't forget to like, share and subscribe my channel. Follow my Techopedia page on Instagram. If you have any question, then you can message me on Instagram. I will give the link of my Instagram page in below description. Thank you.